Hello everybody and welcome back to my channel. So today we're going to talk about the types of numbers. Now you all have studied the type of numbers in your previous classes. You have been taught about all the type of numbers that exist. But I'm gonna talk about a few of the type of numbers that are commonly used in the advanced classes. Okay. So here is a little bit of revision for those type of numbers. So let's have a look at what these numbers are. Okay, so first here we have integers. Now what are integers? Integers are those negative and positive whole numbers. You all know what whole numbers are. Okay, so integers are the negative and positive whole numbers. Whole number is a number which doesn't have any kind of decimal, so it's a whole on its own. Okay, so integers carry the negative sign or the positive sign. We usually don't write the positive sign with the positive number. Okay, now integers. Now let's talk about the natural numbers. Now the natural numbers are those numbers, or you can say are those integers that can be used for counting, like 1, 2, 3, 4, 5, 6 and onwards. Now for counting we always go for positive numbers. Okay, now the next type here is the rational numbers. Now what are rational numbers? Let's have a look. Now, a rational number is a number that can be written as a fraction, like in the form of a upon b, where a and b are integers and b is not equal to 0. Now, you have also studied about the fraction and you know that in case of denominator, it can never be 0 because 0 has no value, and when you divide a number with 0, it cannot give you any answer, right? So, here the condition that lies with the fraction for every fraction is that the numerator can be any number, right? It can be any integer. Like we have said, integers. Integers includes the negative numbers, positive numbers, and the zero as well. But it can never have a zero in their denominators. Okay, otherwise the value will be undefined, right? Now, um, which kind of numbers are included in rational numbers? Like all integers, 1, 2, 3, 4 and all integers can be called as rational numbers, right? Now, all terminating decimals means that all decimals which terminate at some point, right, are known as the terminating decimals, and they are also type of rational numbers. Okay, like let's suppose we have a number like 5.81, which can also be written as 581 upon 100. Now we remove the point and put two zeros with 1 for these two numbers which are after the point. Okay, and similarly 0.6 can be written as 6 upon 10. Now if here you can see terminating decimals are those which don't continue forever, they stop at one point. Okay. Okay, so we talk about the terminating decimals. Another type of decimals is also known as recurring decimals. Now, recurring decimals are those which continue forever. They don't stop at any point. They're going to continue like 0. Here you can see that 0.6666666 dot dot can be written as 2 upon 3. Like 2 upon 3, if you divide 2 by 3, you will all gonna get an answer of 0.6666 and on and on and on. You can also check it in your calculator. Okay, so such decimals can also be included in rational numbers because all of them can be expressed in the form of a fraction. And you must be confused that how an integer can be expressed as a fraction. Now, if you have a number like 3, you can write it as a denominator as 1. You can write its denominator as 1 because anything that is divided by 1 will be whole itself. Okay. So all these integers, all these numbers can be divided by 1 and it will result in the same. Okay? Alright. So integers are rational numbers, and decimals which can be expressed in the form of a fraction or the fraction itself can be are included in the rational number. Alright. Now, what are irrational numbers? Now, rational number and irrational numbers are opposites of each other. Alright, so those numbers which are not rational numbers are irrational numbers. So how are we going to identify it is, an irrational number is a number that cannot be written as a fraction, like under root 2. Now you cannot write a number which is inside the square root as a fraction, and this until it's the complete square root. All right. Now 2 under root 2 cannot be written as under root 3. Now there is 3 is not a square of any number, so it cannot come out of the square root just like that. So it cannot be expressed in a decimal or in a fraction. Similarly, 1 whole under root 2, same case, and pi. It's such a decimal that doesn't stop at any point, but it's not a recurring decimal. It comes with the different values of decimals. You had to round it off at some point. Recurring are those which the last digit continues itself to some till some point. Like let's suppose if you have like 1.307 and it goes like 1.307307. Now same thing continues till the end, till infinite pattern. Now here, if in this case it's like 3.1423657 A614, like this. If a pattern goes like this is not a recurring decimal, or it's not a terminating decimal. So this such kind of thing cannot be expressed in the form of a fraction. Okay, so that's why a pi is not a rational number. It is included in the irrational number category, right?
Because it goes on and on and on, and it doesn't stop at any point.
Okay, right. Let's have a look at some examples, and are going to help you better understand what are rational numbers and irrational numbers. Okay, so here we have these numbers given, like 0.8652 under root 12, 4 pi, 67 upon 19, and under root 64. Now we have to identify which of these numbers are rational numbers and which of them are irrational, right? So let's have a look at the first number, which is 0.8652. Now, we all know that rational numbers can be written as decimals, right? The terminating decimals which stop at one point, or a recurring decimal, like same number or a group of numbers is repeated after each other. Okay? So here, if you can see that there's a terminating decimal here, 0.8652. It can also be written in the form of a fraction like 8652 upon 10000. So, which makes it as a rational number, right? So, this is a rational number. Okay, the next number is under root 12. So, is it a rational or an irrational? By looking at the square root, we can easily identify it as an irrational number. Why it's an irrational number? Because when you're going to open the square root, it's the value that will be given here will be like somewhat like this, 3.464101, and so on. And so there is a random pattern of numbers over here, and they don't stop at any point and they don't repeat themselves, right? So such kind of a number is an irrational number, right? Now next we have 4 pi. Now although 4 is a whole number, but the pi itself is an irrational number, right? So is also an irrational number, because pi also, it's when we convert it into a decimal form, it doesn't stop at any point, or it's not a terminating decimal, nor a recurring decimal. So 4 pi is also an irrational number. Talking about 67 upon 19. Now we have the integer over here, we have the integer over here as well. In the numerator and denominator, both are defined, both have a value, and it's in a fraction form. It's an obvious that it is a rational number, right? Now let's have a look at the last value, which is under root 64. Under root 64 is a square of 8. It can also be written as 8 square. So when you open the square root, you cancel the 2 with the square root sign. The answer is 8. So it's a whole number, it's an integer, and this is a rational number. because we were able to open this square root because the number inside the square root is a square of some number. It's a complete square of a number, right? That's why it is known as a rational number. It's a whole integer, right? So this is how you're going to be asked in the exam as well, that uh, identify the rational and irrational numbers from these group of numbers. Okay, so this is how you're going to identify each of them and how you're going to understand. All right. Now let's have a look at another case. For example, you have a number under root sorry 2 under root 3 plus 3. Now tell I'm going to ask you to ask yourself, is it a rational number or irrational number? You see that there's a whole number, along with it there's an under root 3. The value of under root 3 will be multiplied by the whole integer, plus you're going to add the whole under root of 3 to itself. So whether the entire answer will be a rational number or irrational number. Obviously, it is an irrational number. Reason being, no matter what you multiply the under root with, if the value of if the number inside the square root does not is not a complete square of any number, it will give a it will not terminate at any point. It will not be a recurring decimal. So in that case, it's going to be an irrational number. Under root, um, the number inside the square root, which is not a complete square of any number, includes in the category of irrational number. Okay, so this was it for a little bit of the revision of type of numbers. Let's meet in the next topic, which will be in which I will be discussing the multiples and factors. So meet you in my next topic. Till then, take care and bye bye.